Hello everyone, and welcome to part 2 of the Raspberry Pi Camera with Analytics series. In this video, I'll show you how to view the Raspberry Pi camera's live feed through a web browser. This setup is for local network access only, meaning that all the devices must be connected to the same Wi-Fi network. Since this is a step-by-step series, I will focus on making sure everything works correctly before moving on to the next step. By the end of this video, you'll be able to confirm that the Raspberry Pi 5 is serving a live video feed that is accessible on demand from any web-enabled device that is connected to your local network. Alright, let's get started. Alright, and now let's check if the Raspberry Pi is capable to allow devices in the same network to remotely see the live video footage through a web browser. And in this private network, I'm going to be using 3 devices, a phone, a laptop, and of course the Raspberry Pi. The network these devices are connected to is in the 192.168.6.1/24 network. And for the Raspberry Pi, I have the IP address 192.168.6.131. For the computer, it's going to be 6.47, and the phone is 6.113. Next up, I'm going to open the connection to the Raspberry Pi. And as you can see, I am using VNC because the Pi is not connected directly to a monitor. Functionality-wise, it works the same way, with the only difference being a bit of a lag due to the fact that this is a remote connection. But for these examples, I'm okay with that. So I'm going to open the view to the Raspberry Pi, and I'm going to open Terminal. If you saw the previous video, you saw where I show a command line that you can use to confirm that the Raspberry Pi camera is properly plugged into the Raspberry Pi. And when you run this command line, you can actually create a video clip to confirm that everything works. If you missed that video, this is the command line you can use. rpicam-vid space -t space 5000, which means 5 seconds, space -o, the name of the file, and the extension, which in this case is going to be H.264. I'm going to hit enter, and it's going to start recording a 5-second video in the camera. Once the 5 seconds are done, it's going to stop, and then to see the footage, you run this command line. ffplay, the name of the video clip, and the extension, hit enter, and here we go. Now you see the recorded clip we created with the previous command line. And now let's set up the Raspberry Pi so you can access the live feed of the camera from your local network. I'm going to clear this screen. To set this in the most effective way, first I'm going to install Flask on the Raspberry Pi. Before I install it though, I need to check and make sure I don't have any pending updates that I need to install. So I'm going to run sudo apt update, and it's going to check for updates, and as of right now I am up to date. If you have any pending updates, you can run the command line sudo apt upgrade, and it will install the upgrades for you. In this case, my system is up to date, so I'm not going to run it. Okay, next up, I'm going to install Flask in the Raspberry Pi. So I'm going to run the command line sudo apt install -y. This switch -y means that instead of waiting for the message, do you want to install the package, I'm going to imply that the answer is yes. So instead of getting the message, it's just going to go ahead with the installation. And I am telling it what I need to install. So once that command line is in place, I'm going to hit enter, and it's installed. Okay, it was telling me that I had already installed it before, but if you don't have it installed, that's the command line you need to use. And now with Flask installed in your Raspberry Pi, what I'm going to do is I'm going to create a Python script. And what this Python script is going to do is whenever I run it, it will start mjpeg, and with that, with this service started, I am going to be able to access the live feed from a web browser. In the terminal, I'm going to type in nano to open the text editor, and the name of the script. In this case, I'm going to call it webcam.py. Py, it's because it's going to be a Python script. So I'm going to hit enter, and I am in the text editor. So I'm going to, at this point, I'm going to copy paste the script instead of writing it line by line. Okay, and this is the script that I'm going to be running. And as you can see, it's a short and basic script. This part right here, this function right here, is the one that I want to focus and explain what it does. And this function right here in the script is the one that launches the camera view. It will start it continuously until you stop it. It's on an MJPEG format, and this is the window size, the height and width, and it's going to be recording 15 frames per second. Alright, so now that I have the script in place, what I'm going to do is I'm going to save it, and then I'm going to run the script from my Raspberry Pi terminal. And now to launch the script, I'm going to run this command line. It's Python 3, the name of the file that we just created, and I'm going to hit enter. And if you get this message, don't worry about it. That means the Flask is not optimized to be run on the production environment, but for this lab, it's fine. And now I should be able to go to this website and see the live footage of the camera. So I'm going to open a web browser and go to it and see if I can see the live feed. All right, I'm going to bring the browser 192.168.40.76:8080. I'm going to hit enter, and there we go. I'm going to minimize my VNC terminal so you can see this is just a web browser, and I can see it now. If I move the camera around, you can see there's no lag, it's like immediate. So I know the camera is working, it's capturing the video footage, and I can see it live from my web browser. Now I'm going to move the web browser over here, and I'm going to bring my VNC session back in. And as you can see in the VNC session, I can also see the footage. So I'm going to bring terminal back in, and I am going to stop the process. The footage in the back should stop as well. So I'm going to hit Control C to stop it. And you can see the live view in the back stopped. I'm going to bring my browser back into focus, and apparently I'm still looking at it, but this is just the old image. If I refresh my browser, now that the camera is off, you can see there's no longer any live feed. So I'm going to start it again just to confirm that, and I'm going to Python 3, the name of the Python file. I'm going to run it. I'm going to bring my web browser. I'm going to refresh, and there we go. As you can see, my web browser is capturing the live feed again. If I move the camera around, you can see my hand. All right, so, and you can see there's a little bit of a lag, which that's what I was saying when I first started this video. By running the camera on VNC session, I do have a little bit of a lag, so this is a perfect example on my web browser. If I slide my hand in front of it, you can see it in real time. And now it's going to take a little bit before I can see it on my VNC session. So maybe it was too fast. It just happened. So let me do it again slowly. So this is for the camera, the live feed, which is immediate, and this is for the VNC. So you see there's a little bit of a lag, but it's okay for this lab environment. All right, so now we have confirmed that I can see the live feed from my web browser when the Raspberry Pi is running. So I'm going to stop it, and the live feed in the background stop. I'm going to see my browser, and it should have stopped also. And there you go. And now I have confirmed the remote access to the live feed work through a web browser in my local network. Okay, and that is it for this video. In recap, we set up the Raspberry Pi to allow remote view of the live feed from any device in your local network your computer, your phone, and probably even a smart TV if it has an option to go online or to go to a web browser. In the next video, I will be showing you the basic tools you can install in the Raspberry Pi 5 to do some basic analytics. Thank you for watching. I'll see you in the next one. 3, 2, 1.